At 1033 Intermediate Algebra, Chapter 2, Section 6, which deals with absolute values. First of all, absolute values. The absolute value sign means that it's positive. So this side of the equation has to be positive, which means this side has to be positive. If this side ends up being negative, it's no solution. Also realize that before you can solve an absolute value equation, there must not be anything attached outside the absolute value. If there is, we'll move it over. And you'll see that in example 6. So the first thing we do is we've got to realize there's two possible answers in here. There's a positive value and a negative value. So what happens here is we set it up as 5w plus 3 equals 7. And then 5w plus 3 equals negative 7. Both are two steps. So subtract the 3. Divide by 5, we get w equals 4/5. If I take that 4/5 and plug it back into here, I get 20/5, which is 4. 4 plus 3 is 7. Absolute value 7 is 7, so that works. Come over here, I subtract the 3, I get negative 10. Divide by 5, I get w equals negative 2. If I take that negative 2 and stick it back in there, I get negative 10 plus 3, which gives me negative 7. Absolute value negative 7 is 7. It works as well. You must always take the solutions that you get from an absolute value, plug them in, and make sure they work, because sometimes they don't work. Coming down here to example 3, same situation. This side's got to be positive. This side is already positive, so we're good to go. We don't have anything attached to the outside, so we can compare both sides. Positive, positive, we're good. So we get x over 2 minus 1 equals 11. X over 2 minus 1 equals negative 11. Add the 1, multiply by 2, we get x equals 24. If I take the 24 and put it in there, 24 over 2 is 12. 12 minus 1 is positive 11. Add the 1, we get negative 10. Multiply 2, we get negative 20. Take the negative 20, put it in there, divided by 2 is negative 10. Minus 1 is negative 11. We're good to go. Now, example 6 has a couple of different things in here that you've got to pay attention to. First of all, this 2 on the outside, I got to move. Same with this plus 25. Remember, the absolute value must be by itself before I can begin to solve the problem. So the first thing I did was subtract the 25 over, which gave me negative 2. Then I'm going to divide by 2, which gives me negative 1. Now, absolute value of x is going to be positive. How can it be equal to a negative 1 if this side is supposed to be positive? So this is no solution. You've got to check them. Here's example 8. In example 8, we have two absolute values. No biggie. We're still going to take the 3x plus 2 and set it equal to 5x minus 8, which means we didn't change it. And then what we're going to do is go 3x plus 2 equals negative 5x minus 8, because this whole side has to be changed. This gives me, if I subtract the 5x over, it gives me negative 2x plus 2 equals negative 8. Subtract the 2, I get negative 2x equals negative 10. Divide by the negative 2, I get x equals 5. If I take the 5 and put it in here, I get 15 plus 2, which is 17. If I put the 5 in here, I get 25 minus 8, which is 17. Works. Coming over here. First thing I got to do is distribute this negative. So this becomes 3x plus 2 equals negative 5x plus 8. Don't forget to distribute to both terms in the parentheses. Add the 5x over, I get 8x plus 2 equals 8. Subtract the 2, I get 8x equals 6. Divide by the 8, I get 6 over 8, which reduces to 3/4. If I take that 3/4 and plug it back in here, I get 9/4. Which if I change this to fourths, this will be 8/4, which gives me 17/4. If I take this and put the 3/4 in, I get 15/4. This gives me negative 32/4, which if I subtract, I get negative 17/4. Remember, absolute value of a negative is a positive, absolute value of a positive is a positive. This works, so the solutions are 5 and 3/4.